7.2 equilibrium law in chemical reactions. So what is the equilibrium law? This is the general chemical reaction. A capital and B capital is your reactant. Lowercase a and b is the coefficient. Capital C and capital D is your product, and the lowercase c and d is the coefficient. So the equilibrium law is saying concentration of your product, the power of coefficients, divided by the concentration of the reactant to the power of their coefficients. Concentration of C to the power of C, concentration of D to the power of D on the top, concentration of the A to the power of A, and concentration of B to the power of B in the denominator. So let's just see. Here is the reaction. We have, if you want to find a right the K, going to be concentration of HI power 2 divided by concentration of the I2 and concentration of the H2. As you see it's here, that's the law is equal to K. And this K constant, doesn't matter what are you doing. So if you have this table, you have trial 1, 2, 3, concentration of that each is given to you. If you just calculate that with the equation of the K constant, you will get the same value for K. The equilibrium constant and reaction kinetics. Just look at this. Write the equilibrium law expression for a reaction in which nitrogen gas react with hydrogen gas. The closed system to produce gases ammonia as the only product. So N2 plus H2 gives you NH3. We balance it. Then we use the K constant law. Here is product is NH3 to the power of 2, H2 to the power of 3, and N to the power of 1, because the quotient here is 1. Here, the question, the first question is practice. Nitrogen and hydrogen combine to form ammonia. Again, you have the same thing as previously. You know how to establish the K constant. The concentration of each in equilibrium is given to you. So make sure this concentration is at equilibrium when you put that in the K constant. Concentration of NH3 is 2, 10 power of -4, so you put that power 2. Concentration of N2 is 1.5, 10 power -5 here. Concentration of the H2 is 3.45, 10 power -1 here, 10 power 3. Just calculate that. K value is 6.49, 10 power -2. Calculate the value of equilibrium constant, composition of the ammonia at 500. So here is the reverse of that, right? Here is H2 and H2 combined to give you NH3. Now here is NH3 is decomposes to this. So again, the product, you have N2 and H2 here. Here H2 to the power of 3, N2 to the power of 1, divided by NH3 to the power of 2. Just put the concentration from previous question here, and you get 15.4. So question number 2 and 3 is a practice. This is page 444. So when you write the equilibrium law here, you consider the gases. If you have a gases, just have one phase. And the reverse, if you want to do the K prime is a reverse reaction. The K constant for the reverse reaction is simply is equal to, K prime is equal to 1 over K, or K is equal to 1 over K prime. So you can do question number 4, 5, and 6 as a practice. This is page 445. So homogeneous equilibrium is the equilibrium in which all entities are in the same phase. As everything is gas, or everything is liquid, or everything is aqueous. Heterogeneous equilibrium in which reaction and product are in more than one phase, is like that. H2O liquid gives you the H2 gas and O2 gas. make sure when you want to write the K constant law, you do not write liquid or solid, because a liquid and solid will not change the concentration. So in this reaction, so we just write for H2 and O2. We don't consider the H2O liquid here. But this is the overall rate law reaction. Okay, let's look at direct equilibrium law for this decomposition. As I say, we don't consider any solid. But to write the law, the product divided by the reactant. Reactant is solid, so we don't have any denominator here, as you see. So consider NH3 power 1 HCl to the power of 1, and then with the rate law. Here is another one, so writing the constant K here. T2 of them is solid, so you should ignore it when you write the law, just CO2. But K is just concentration of CO2, which is your product here. Here, if you have ionic equation, so you have to expand it. You have to cancel the common ion from both sides, and then this is what you have. Make sure when you're writing that, you should not consider the solid. That's just the concentration of Zn divided by concentration of the CO, as you see here. You don't write as solid and solid. To practice, you can do question number 7 on page 447. So look at the K constant in this reaction. CO and O2 react to give you CO2. As you see, this is 3.3 10 power 91. It's a huge. It's just saying that CO2 is your product, right? CO2, the numerator was much more bigger than the denominator. That's why it's a very big number. So it means you have a high concentration of the product compared to the reactant. If the K is close to 1, like 0.9, it means that the concentration of the product is same as concentration of the reactant. That's why writing them is going to give you 1. If the K is very small, it's just saying that denominator is very big. This concentration of your reactant are much more bigger than the product. Here, this is the summary of what I said. K is is much more larger than 1, so its concentration of product is much more higher than reactant. K equal 1 means concentration of the both reactant and product are the same. K is much more less than 1. It means concentration of the reactant much more than the product.